Good morning, everyone. Welcome to the first, real talk, I would say, today about some developer topics. I'm Bart de Smet. I'm actually going to talk about TypeScript here today. I'm a developer at the Online Services division at Microsoft. Before that, I used to work in the Services and Tools business, STB, where I worked on reactive extensions and various other technologies. And it's kind of funny to sort of talk a little bit about that because as I joined OSD, my worst nightmare sort of came true, right? Like, in OSD, because you're doing online services, which includes things like Bing and Ad Center and MSN and so forth, the main language to use there for anything that surfaces, the end user is really JavaScript. Like you have all those websites, you have, gigantic applications that are actually built using JavaScript. And so the reality is that application scale development using JavaScript is pretty darn hard. And the reason I was never really a big fan of doing pure JavaScript coding is like, dude, where's my static type system and where's my, go-to definition and refactoring utilities and all the nice conveniences that you're getting accustomed to when you're doing things in C# and Visual Basic and, for that matter, even C++, has better tooling in some sense. And so, well, what's really the case there is that JavaScript was is this language that was built really for 100-line applications a long time ago. It was just there, to allow you to do button-click handlers, on a tag in HTML, and then maybe do a window.alert function, but not really have any kind of large-scale structuring capabilities. In fact, the biggest construct that you have in JavaScript that you can use to emulate a lot of behavior is the function, but as it turns out, doing everything and squeezing everything through functions to emulate classes and modules and all of that kind of stuff is pretty tough, and everyone has to do it, and you need to learn all of the quirks of the underlying language to be successful. And so we heard increasingly from different teams within Microsoft and outside that doing application-scale JavaScript is really hard. So this is where, of course, TypeScript comes into the picture. So what TypeScript is really, it's a language that's actually a superset of JavaScript, and I will talk a little bit about that in just a second. But that's really aimed at doing this, application-scale JavaScript development, which means we introduce things like, optional static typing, things like, modules, classes, things that you need to structure, large-scale applications, really. And so if we go into the real definition, meaning less of a marketing definition, if you will, you can think of TypeScript as being a superset of JavaScript, which means that every single JavaScript program that you have today, every library that's out there, is also a valid TypeScript, piece of code. So TypeScript just extends JavaScript as it is today, and in fact, also including some of the future-looking ECMAScript 6 features, but it extends it with some things like optional static typing and so forth. Now, at the end of the day, when you write some TypeScript application or some TypeScript source, the compiler, which, by the way, is completely written in TypeScript as well, and we'll take a look at that one later, actually translates your TypeScript code into JavaScript. So at the end of the day, it's simply JavaScript. Like, it's just a translation of some syntactic conveniences and some additional things that we build on top of JavaScript. So let's talk a little bit about what this means. Well, the implication, of course, is, we want to make development, large-scale development in JavaScript much easier. So we want to have, all of these rich capabilities that you're used to in, for example, C# and Visual Basic, meaning things like, code navigation, refactorings, and so forth. And the reality is that today's tools are darn good at doing those kind of things by actually leveraging static type information. So we add this optional static typing to the language, but at the end of the day, it's still plain JavaScript. And that means that you can use TypeScript to work with any browser, any host, any operating system, everything that really JavaScript shines at. We don't want to bastardize the language so that you can't use it for specific targets. Now, one additional thing there is that the entirety of TypeScript is open source. This includes the compiler itself. as well as everything that has to do with language services. And we'll actually see that we can use TypeScript inside a browser to do some code editing. We also have a plugin for Visual Studio, but people can take it and actually build it into different IDEs for example, doing development for other platforms. So let's take a look at some more of the details, and then we'll go into some extensive demos here. So the first thing that's very important to point out is that TypeScript starts with JavaScript. Now, there are a lot of people out there that say, well, JavaScript isn't a great language, let's do a different language. We have a lot of competitors that say, the way to make the world better is by creating a new language, and it doesn't have anything to do with JavaScript to begin with. A good example of that is actually Clojure, which is a language that transpiles, transcodes and compiles into JavaScript at the end of the day, so it can still run everywhere. But in order to use Clojure, you have to start learning a totally different language with different keywords, different syntax altogether. So it's not a superset at all. So with TypeScript, we say we start with JavaScript, which means that all JavaScript code today is also recognizable as TypeScript code. You can just copy-paste existing code and light it up in JavaScript, in TypeScript, I mean. And it also means that you can just cross-reference any existing library that you have, like jQuery, Dojo, XJS, all of those things, including, for example, WinJS for Windows 8 modern UI applications. You can just cross-reference that from inside TypeScript. Now, of course, we add something to it, and I've already mentioned it a number of times. The things we add is optional static types, and I will explain what that means, this optional part. We add classes, we add modules as well. Now, one very important thing to point out, and then we'll get into some examples here, is that we don't add any runtime overhead, which means that the code that we actually compile into the JavaScript that we produce is actually as close as possible to the code you would have to write manually to emulate the behavior using well-known patterns. For example, if you declare a class in JavaScript, the way to actually create private variables is by creating a function that uses a closure over some variables and then apply the function and yada, yada, yada. Like, we basically compile into those patterns, but we don't really touch the code that's inside your function blocks. Like, what's inside your function block is just preserved as is. So we basically compile out all of the static typing, which is really all there for tooling's sake and for tooling support, but at the end of the day, it's just JavaScript. And so that's what we mean by saying it compiles into idiomatic JavaScript. It's the JavaScript that you would have to write otherwise by hand in order to achieve the same effect. And so, as I said, it runs in any browser, any OS, and any host platform. So let's actually take a look at TypeScript right now and do some extensive demoing here. So let's take a look on the TypeScript website to start with. So what we have here is typescriptlang.org, which is your starting point to start learning about TypeScript. In fact, you can just play with TypeScript in the browser over here, because the TypeScript compiler itself is just, of course, written in TypeScript, which means it can run anywhere JavaScript can run. And I'll give you some more examples of that in just a second. Now, when you click the Get TypeScript Now button, and I'll talk a little bit about that later, you can also get plugins for Visual Studio so that you actually get some richer tooling around the TypeScript editor. And we'll talk about that one in just a second. But let's start with just the playground over here. And it turns out I already have something sitting over here. But let's actually start really small. So what you're seeing here is just an HTML website that references a TypeScript compiler. And whenever I type something on the left-hand side, it's going to compile your code into the thing on the right-hand side. And that's really like, how fast the compiler is. It means like every time you hit a key, it can do the whole recompilation. In fact, like, if you're in Visual Studio and you just save your TypeScript file, at the point of saving the file, we emit the corresponding JavaScript file. So it's really not that much different from like just doing JavaScript development to begin with. It's totally unlike things like C++, where you have to compile and get a cup of coffee, and then come back and then you find 5,000 error messages, right? So it's super interactive. So let's actually write some piece of code over here on the left-hand side. So let's just start by, well, actually, let's start without doing even a function. Let's just say var x, right? And let's say x equals 5. And you see, like, the thing on the left is TypeScript, and the thing on the right is JavaScript, and they just happen to have exactly the same shape or form in this particular case. Like, there's nothing special happening here. And that's because TypeScript is really a superset of JavaScript. Now, I can get a little more fancy about this. Let's actually hover over a couple of things over here. Let's do the hovering in just a second. Let's actually use some feature called optional static types to declare our intent, and then we'll start, building up from there. So one thing I can say here is like, I want x to be a number. So I can specify those optional static types by using the colon syntax. And it's in fact, because it's optional, we put it at the end. So it's not number x, it's actually var x is a number. Just like, dim x as number in Visual Basic, if you will. But so you see on the right-hand side, there's no manifestation of that type that I have declared over here. It simply looks like var x, x equals 5. Like the type simply compiles away. Now, as I do this, I cannot start violating certain things over here. I can't assign hello to x, because obviously hello is a string, and I should not be able to assign it to something that's declared to be a number. Now, why would we care? We can still run this thing in JavaScript and it will do something, but that's actually where things get really brittle. Is like, you want to know what exactly is going on here, and so tools can start helping out a lot if they can analyze the types that you're actually dealing with. So let's now change gears here and declare something more elaborate, namely a function. So let's declare a function called process that takes in an x over here. And now in here, we'll just do some stuff, right? Let's actually do something really simple. Let's say, x.name equals foo, right? And then I'll say var y equals x plus x, and I will return, y over here. So a very simple piece of code. Adding some property called name to the object that's passed in, then doing some addition, and ultimately returning the result. Now, what's interesting about this piece of code is that if you look at the types over there, TypeScript infers some type for it. It wants to know, like, what's exactly going on over here. And you see that this is a function that takes in something of type any, which is like system.object for JavaScript. It's like the top type, the most encompassing type that contains anything else. And it says, like, I can't make any more judgments about this. Like, it takes in an any and it returns an any. Like, I can't reason about it any further. However, you can start lighting things up using the optional static types again. So you can actually say over here, let me declare x to be, for example, a string. And as you do that, you tell TypeScript that really the intent is that this thing should be a string. You see some red squigglies that say, well, this doesn't quite make sense. You can't really access something called name on top of that thing. Now, just adding that single type annotation opens up for a lot of tooling capabilities. You can simply dot into it, and now you know what you should look on, on websites for traditionally. Namely, what are the members on a string in JavaScript? So you can start, looking into this, and you see the signatures and all of that stuff. So in fact, you even get the illusion that JavaScript has overloads, and I'll talk a little bit more about overload capabilities later as well. So let's actually do something more here. Let's say alert of y as well. So alert is this built-in function, right, that allows you to alert something, and that takes in, as you can see over there, a string. I will explain the question mark later. It means it's optional. You don't have to pass in that parameter if you don't want to. But you see, like, this thing doesn't complain because y clearly is a string, and so the types line up. However, if I change this thing over here to be a number, now you see that other things aren't quite happy, right? It now says, well, you can't alert the number because, well, the number isn't a string, right? However, if you hover over a couple of things here, the IDE can infer a lot of types. It knows that, if you do x plus x, where x is a number, the result will also be a number. So you see, like, a little piece of type information at the top of your file can actually spread throughout the file and do a lot of type inference to actually see whether things are sound. Now let's do one more thing here. Say that x is actually a Boolean. At that point, I can't even do x plus x, right? Well, it turns out you can. You can run a program in JavaScript that adds two Booleans together. And then you end up, in something like WAT, WAT is actually a video that you can find on the interwebs. You just look on YouTube and you search for JavaScript WAT, W-A-T. There's a guy who actually looks at, like, what does it mean to add, an object together with a double or something? And in JavaScript, everything has some meaning, but it turns out that, it doesn't really have any sensical meaning in a lot of cases. So adding two booleans together, God knows what it will actually do. But very important to point out is, like, if you want to run this, we don't prevent you. This compile error is just a warning, essentially. Like, it still does the compilation, as you can see. It produces JavaScript files on the right-hand side, so you can actually just execute this code and just run with it. But you see, like, a lot of things start lighting up here. So let's actually simplify this thing a little bit and say, process takes in a string, it duplicates the string, and as you can see over here, y will just contain, y will be inferred to be of type string, as you can see. And now the alert function actually works. Now, I can do much more, of course. Like, this would be kind of sad if that is the only thing in TypeScript. So what else can I do? Well, it's not uncommon in JavaScript to actually pass parameters that have some more structure to them. So we have also richer types than just, the primitive types, being Boolean, number, string, and the any type, in fact. So what are the other types you can actually build? You can actually build arrays. So you can say, like, X needs to be a string array. And so at that point in time, well, you can't add two arrays together, obviously, but you can index into them. You can say, like, X sub 0 dot, and you see, like, the whole IntelliSense for things that are in array types. So you actually can declare those arrays. Again, at the right-hand side, it doesn't really show up. It's purely a tooling convenience to do those type annotations. So that's another type you can actually put here. Yet another type you can do is you can declare a function. You can say, like, X needs to be a function that takes in mapping and then returns a string. This is using the lambda syntax, but in the type declaration space, the lambda syntax that you're also used to from C#. So you can say X is something that takes in a number and a Boolean, for example, and returns a string, which means that over here, I have to do X open parentheses, whoops, the IDE has gotten more interesting here. And you see, like, it gives you, like, the IntelliSense saying, I want to get a number and I want to get a Boolean over there. So I can actually pass in 42 and true. And then you see, like, this thing returns a string and the type starts flowing again, right? I can hover over the Y over here. It sees that that thing indeed is a string. And things light up with regards to using the alert function. So pretty standard stuff here. Now, one more thing you can do is you can also declare structural types. So what a structural type really is it's basically a description of a bag of properties. You want to say, like, this function wants to take in an X, a Y, and a Z, and so forth, and you want to define that particular structure. And so for that, we actually do have the notion of interfaces. So you can say, I want to take in an interface here that describes, say, for example, a person. Okay? So interface person is something where I want to declare, say, two things. I want to declare a name, which is of type string, and I want to declare, I want to declare an age, which is a number. Okay? So at this point, I have something that lines up with anything that obeys to that contract. And I will explain in just a second what that means, but I can now start writing things like X needs to be of type person. And then once I go in here, I can do X dot, and you see, of course, as you expect, it has an age and a number, and you can start playing with it. So I can actually say over here, and this is starting to become a little bit more useful at this point, hello X dot name, for example. So now how do you call this function, right? How do you call this function? How do you declare something that implements the interface? Well, TypeScript in its very nature is structurally typed. Okay, so there are two different ways of thinking about type systems, basically since type systems were invented. One way is to think about them in a nominal fashion. Nominal means that in order to declare that something is a person, it needs to explicitly say, I'm going to extend the person, and then I'm going to implement all the members that are required, and then you end up with something else that has a name, like, a person implementation or something. In a nominal system, or in a structural type system better, you can just pass in things. So I can say process over here, and I can pass in an object that has the right shape. So I can say, I want to take in something that has a name over here, called Bart, right? And something that takes in an age, and I will lie about the age over here and say 21. So as you can see, this now lines up. Like, it simply says, okay, this is fine. This actually completely type checks. In fact, you can add more things to it. It's basically the minimal thing that you need is a name and an age, but you can actually put other things in here, like, well, I don't know, like, city or something, right? I can say city equals Bellevue or something. So you can just add things to that the function isn't interested in, so it can simply declare what it wants to see on the input. Now, of course, if I don't specify age over here or have a typo, at that point, process is not happy anymore, and it says, well, look over here, like, I want to have something that, matches person, but you passed in something that has a structure of name equals a string, age with double E equals a number, and city equals a string. That doesn't quite line up with anything I expect over here, so please correct that. And so you can just do the correction over here, and things are happy again. Now, you don't have to declare even those interfaces if you don't want to. You can actually simply describe them in line. So in case you don't want to really have this artifact that other people can reference, you can also just do things in line over here. You can say X needs to be something that has a string over here and that has an age of type number. So you can just declare that thing in line and you don't really have to have all of that stuff sitting there. So there are various ways of actually specifying those types. You can actually give them a name so you can refer to them. And in fact, as we will see later on, you can actually export those things out of modules so other people can refer to them as well. That's where the large-scale application development aspect comes in of TypeScript. But you can also simply do what I'm doing over here. So this shows a couple of interesting things you can simply do at the the space of functions and at the space of types. So let's take a look for fun and giggles. Let's actually just switch gears now and go into Visual Studio to show that we can actually run exactly the same TypeScript compiler in Visual Studio with some more rich tooling around it. So this is great to actually do some playing around, but you can actually also do all of that stuff in Visual Studio, of course. So what I have here is, once I basically create a new file over here, I do have, when I install TypeScript, just an entry called TypeScript file. Not very exciting, right? But this thing creates a .ts file that will be fed to a compiler called tsc.exe, which is basically just a wrapper around the Chakra JavaScript engine, because the TypeScript compiler itself is written in TypeScript, so it can run anywhere you can actually run JavaScript. So let's just copy all of that stuff over here and just start playing a little bit more on this side. So one of the things you see, of course, is like things start lighting up in the IDE as you expect. You can see, the members. You can do things like, go to definition, which isn't super exciting to just jump between lines over here. But, we'll start seeing much more files included later on. Now, one thing you see on the right-hand side as well, and I'll talk a little bit more about that in just a moment. What you see over here is a virtual project. And so TypeScript doesn't start with this notion of a project. Like, you can simply have multiple TypeScript files that refer to each other, and you can simply open one TypeScript file, and the thing will just chase all the references that you have to basically create a project on the fly. It's just something that exists in memory. You don't need to have a tsproj file or something like that to start playing with TypeScript. So in this case, I just opened file1.ts, and it actually shows that it also references something kind of mysterious, which is called lib.d.ts, which is actually the declaration file, and we'll talk about it in just a second, of the DOM and JavaScript. So this is actually where it starts knowing about things like the alert function. If I go over here, you see, well, where does alert come from? Well, there is something like mscorelib, a standard library that's been referenced by default here, and I can actually just go there and start doing things like go to definition. And then you see I'm now actually in the declaration file that describes everything in the DOM that you find in any conventional JavaScript execution environment. Okay, so let's elaborate a little bit more on the things I wrote over here. Actually, I shouldn't have removed the interface person. So what we're really doing here is we are modeling what you will find at runtime in JavaScript and put some static optional typing on top of it to light up tooling support. Now, if you think about functions, like, for example, the functions you have in jQuery, The way that people do functions and overloading in JavaScript is really by having a whole bunch of overloads emulated to property bags. Right? You have like the dollar function in jQuery, you open the parentheses, and now you have a whole bunch of different configurations that are basically checked at runtime. It says like, do I have 2 or 3 parameters? If the first parameter is a string, then I will do this, and so forth and so forth. So what you can do here is you can actually model optional parameters using optional properties. So you can say, I have a process which takes in a name, right, which is of type string, and which has an age, which is of type number. But I also want to have, this city passed in, but it shouldn't be there all the time. Like, I can just greet somebody without having the city of that person. But if the city is there, I want to do something else, for example. So I can actually declare optional types as well. I can say, like, this is an optional property, city question mark, is of type, in this particular case, a string. And so now I can pass in over here that this thing is really a person. You see things are lighting up at the bottom. Like, I can do name, age, and city. That's fine. I can also run without a city if I really like to, because it's optional, so you don't have to pass it in if you don't like to. But if you do pass it in, it should be of the right type. So I can't pass in city equals true because, well, city, if it's there, it needs to be a string. So you're basically modeling the things that otherwise you have to learn in things like JavaScript documentation files, where it says, the first parameter can be a string or an int or a bool, in case the second parameter is this kind of thing, and the third parameter is that, and that's the way, people do overloading in, for example, JavaScript. So this is one way of actually modeling what you will actually find at runtime in JavaScript. Okay, so let's actually switch gears a little bit over here, and let's see what else we can do. So let's actually import some other thing over here. I started with person, but just for fun and giggles, let's do something else. I have a process method that takes in a thing. A thing contains a number and a string, and then I can just do some interesting stuff with that, of course, over there. And as you expect, you will have full IntelliSense over here. Like, this is a number, so I can do 2 exponential, I can do all of those things, which are standard functionality in JavaScript, that otherwise you will have to find out using documentation. So as I said before, you can actually just call this thing. This is just talking about the things that we already saw. However, you can also have more than just properties, of course, on those interfaces. Those interfaces can also contain functions. You can actually say, I want to declare an interface that contains, some method. And so the way to do that is by actually, declaring just a function in there. And so that's what I'm doing here. I'm saying, I want to have a property which is of type number. I want to have a property that's of type string. And then I want to have a function there, okay? And this function takes in a string and returns a string. Now, wouldn't it be nice if you can also do overloading, where we can say, like, I want to describe what jQuery looks like. I want to describe a jQuery interface that has the $ method on it. And then I want to sort of, give you the illusion of having overloads, even though at runtime there is no such thing as overloads. How can we actually do that? Well, in TypeScript, we can actually say, at runtime, we know that something will pick up something that takes in a number and returns a number. I want to declare an overload for that. So I can basically say over here, foo takes in a number, okay, like this, and returns a number. And so as I do that, like, I can now actually go over here, and I can actually go in the function that uses a thing, and I can say x dot, and you see a and b, just as you expect as properties, but you also see foo over here, which has 2 overloads. So you can basically just get this, illusion that, at runtime there are overloads. Of course, they do not exist at runtime, but you can't actually mix and match 2 things that aren't compatible. So you can actually describe all the call signatures that you can expect there to be. So that's the idea of basically modeling what you will find at runtime. In fact, TypeScript is really a static type system for tooling's sake, so that when you're actually writing your code, you catch errors much earlier. In fact, this is also by itself an illusion over some other features of TypeScript. So here I have 2 overloads of foo, but in reality, this is kind of the same as saying that foo is itself an object which has 2 call signatures that I can actually describe over here, like this, without this. So this is actually the same. This is a foo that when you dot into it, it has two ways of invoking that particular thing. So I can actually do x.foo. It's just syntactic sugar. I can do x.foo, and now you see, like, this thing has two ways of being called. Okay, that's some notion in JavaScript that everything, can have this callable property. In fact, like, even functions can contain some data. Some frameworks actually leverage that. They say, I want to expose something that's callable, so you can call that function, but I also want to have some property back on top of that. So I can actually put some data property here, for example, and say this is of type any or bool or whatever. And so now, when you actually go to x over here, you can go to x.foo, you can still call that thing, but you can also dot into it. Some frameworks use this to actually, tag on some value to the functions that they leak out. So TypeScript simply wants to model all the things that, people do in JavaScript at runtime, but give you this nice, static tooling experience on top of that. Now, for completeness, there are some other things you can do over here as well. You can, in fact, say how to new up an object, for example, and you can also have indexer support over here. So you can actually say, when you index into this object using a number, I want to return, say, an element over here. So now I can actually go to x.foo, and I can also index into it. Because, some people actually supply indexer support on those kind of objects. So I can do also square bracket over here. Now, if I do x of foo of 42, and I dot into it, you see the IntelliSense light up for element. So, all the types are just flowing throughout your declaration over here, and your usage, of course. So that's what's going on over here. You can also declare constructors here. Let's just skip that part. No, what the heck, we have constructors over here. So constructors are just using the new keyword over here. So those are some of the things you can declare on interfaces. So now let's actually show some other example of building, an accumulator. And this is really interesting because it shows the power of optional static typing. Okay? So what I have here is an accumulator, or a make accumulator function, that uses a very common pattern in JavaScript to actually have private state. There's no such thing as classes in JavaScript, and we'll actually see that TypeScript does have those. But in order to actually declare something that has a private field called sum, people typically do make accumulator that returns an object that then has three functions in it, right? And it closes over that sum variable, so it's actually private state for the accumulator. So I can just do make accumulator over here. And then, as you can see, make accumulator returns an object that actually has a clean method, an add method, and a result method. But notice one thing. It actually knows all of the types. It knows that the result returns a number. It knows that add actually takes in a number and returns a void. Well, I've just given it one hint in one place in this particular case. I've said, the value that you pass into add is a number. And based on that, it has inferred everything. Like, it has also inferred starting from sum. It knows, well, sum is assigned 0 to begin with, which means it has to be a number. So the result, which is a function that returns the sum, has to be a function that returns a number, right? So things just flow in this world. So I can just say var acc for accumulator, and I can say accumulator.add of 5, I can do accumulator.add of 3, and then I can do accumulator.clear, for example. Oops, that should be acc. You see, like, I'm already catching my mistakes over here. And now I can simply do result.toString, for example, and do an alert function on top of that. So you see, types are flowing, and I can't really go wrong here. Like, I can do the things that do make sense at runtime. Even though you can totally write in JavaScript, toString, and, it's fine, and it will produce undefined at some point, or, do some other weird behavior, and then you will have to chase down where you actually made that mistake. So now, what's super interesting about this is really that, I just had to drip in a little bit of, typing in this piece of code to actually light it up. Now I can also describe this whole thing, this make accumulator, of course, using an interface. I can basically say I want to have an interface called accumulator, just to drive home the concepts of interfaces in TypeScript. And I can say, this is an interface that really has, a method called, or a function called clear, right, which returns a void. I also want to have, an add, which takes in a value or an x, x which is a number, and it returns a void. And I want to declare also a result function over here, which takes in nothing and returns a number. Now, as I do that, I declare the types up front. I can actually have the types being inferred from another way. I can actually say, you know, this make accumulator, I want this thing to return an accumulator, right? And at that point, you know, I don't have to annotate the value to be a number over here. Like, you know, it just needs to light up, right? You know, it just needs to line up. And in fact, if you hover over it, it actually says, well, you know, if you're implementing an accumulator, this thing clearly has to be, you know, a number. So it actually checks the other way as well. Now, this is very useful because of, you know, the DOM, where you want to do things like window.onMouseMove, right? And now you want to say, like, you know, I want to assign an event handler for mouse move over here. Now I want to say function E, and now in here, I want to dot into E. And of course, I want to see whatever the thing is that's being passed in. So it knows that mouse move is actually declared to be a function that takes in some DOM object, and now, you know, E is inferred to be, well, I don't know what it is, a mouse event. And I can go here and right-click and go to definition, of course, and then you will see that, you know, mouse move actually takes in a mouse event. And I can go to definition over here, and this thing says, well, it's an interface, that's a UI event, and so forth and so on. And this is actually the definition. Now, let's actually step back a little. What's this mysterious file all about? Well, this file is a so-called declaration file. It's actually recognizable by .d.ts. And so this file itself is actually an 8,000-line file that describes, you know, the DOM. You know, what's basically available to any JavaScript host. So you have things like window, alert, and all of those kind of things. Now, this was simply, you know, built from, you know, the online specification of ECMAScript, for example, just, you know, doing a transliteration of what's on the website into code. Now, we also have declaration files for other frameworks. Frameworks like jQuery, Node.js, you know, all of those frameworks have declaration files, and the community is actually actively contributing a lot of those declaration files. And once you have that declaration file, as you can see, you can start dotting into things, right? You can just, you know, follow the types and, you know, follow the IntelliSense along. And so we'll actually see some other file in just a second. So this shows how types can actually flow in TypeScript. So let's actually now start talking about what you can use in TypeScript to build, you know, big applications. And in order to write big applications, you really need to have this capability of structuring your code in, you know, components and reusable units of code. And so two very invaluable concepts there are, of course, classes and modules. And in fact, you know, JavaScript has modules with, you know, AMD, asynchronous module definitions, and so forth. And in fact, a lot of people also have classes in JavaScript by actually emulating them using prototypes and all of that kind of stuff. So in TypeScript, we do have support for classes. So let's switch back to the IDE over here to sort of see what a class looks like in TypeScript. So I can say, you know, class person over here. And now I've just declared the class person, and this is the standard pattern that people use to actually declare classes. In fact, like, you know, ECMAScript 6 has the proposal of defining classes in the language specification. And then, you know, you will actually have the syntax that appears on the left. So TypeScript already takes some of the ECMAScript 6 features, but it can compile that code into different standards. It can compile it into ECMAScript 5, ECMAScript 3, and so forth. So in this particular case, we already have an ECMAScript 6 feature, but it basically compiles into what people would write manually otherwise. So this is the way to actually do class definitions in JavaScript. So let's now actually add some stuff to it. So let's actually add a name, which is of type string. Let's add an age, which is of type number, right? And you see nothing is being added on the right-hand side because, well, those are, you know, artifacts that will be there at runtime. But, you know, there is no place in JavaScript to declare them up front. Like, you know, you will have to assign to them at some point for them to come into existence. So in order to do that, you need to have some constructor. And this is actually using the ECMAScript 6 proposed syntax. So you actually have a constructor which takes in a name of type string and an age of type string. And now in here, I can say this.name equals name, and I can say this.age equals age, right? So pretty standard stuff. I can just declare that stuff, and as you can see over there, it just generates a function that's called person as well. So if you actually do new, it will actually call that one. So pretty standard JavaScript stuff. I can write var p equals new person over here, and now I can pass in. Oh, here you see things are not type checking. I have an age of a type string and it wants to assign it to a number, so that's a good catch. So let's just put in number over there. But so now I can call over here person with Bart, and I can pass in 21 for the age over here again. Okay, so that's pretty good. I can just new up those objects, and I can dot into them, and well, you see that you can access the age and the number in this particular case as well. Now, you can do some other things over here as well. You can actually have default values. You can say, like, the number by default needs to be 21. Again, an ECMAScript 6 feature that's actually proposed. In this particular case, we'll just generate a very little piece of code over there that says if the age is undefined, age has to be 21. So we can actually basically emulate that kind of behavior. Now, in fact, this is a very repetitive pattern that a lot of people have to write, namely declaration of fields and then doing this.that, and so forth, like all those assignments and constructors. In order to make this code a little easier, we also have this notion of automatic properties. So you can actually say, I want to declare a constructor that has 2 parameters, and those parameters need to show up as fields as well. So I can just say over here public on that thing, public name string, public age number, can get rid of all of that piece of code as well. So a pretty large simplification of the code. This is just creating basically a property bag that has some constructor that you can actually use. And I could still make things optional over here, so I don't have to specify them like that. So this will actually use person with the default value being 21. Now, of course, I also want to add some members to this thing. Like, otherwise, it's kind of ridiculous to create this class to begin with. So let's actually, just, switch back to Visual Studio for a second and take a look at classes over there. We've sort of seen like how they compile in terms of a function on the right-hand side. But let's actually just, play a little bit in Visual Studio now. So let's actually just have a, where were we? We were actually at this point. In this case, instead of using a person, just, to give you some other example of the same concept, I'm going to use a class called point, okay? And so I want to add a distance method on top of that thing. Well, how do you declare a method? Whoops, it's actually the full snippet. My apologies for that. How do you declare, a function that's available, or a method that's available in a class? Well, you simply give it a name and, give it a parameter list, pretty standard stuff, right? So I just have a distance function here, takes in no parameters, and as you can see, if you hover over this thing, it actually says it will return a number, because that's what mat.squareroot actually returns. Again, this is something that, is part of the standard library, so you just have IntelliSense for that one available. So now that I have this, you can do some other things that are also available in ECMAScript 6. Like, for example, you can actually say over here, like, this is really getter. Like, people should be able to use this as a property accessor. That's a feature that ECMAScript also wants to add. But you can do something more. You can also have static members. So you can actually say static, origin is a point, which is equal to, and now I could actually say, I want to declare something that is a point, that, has coordinates 0 and 0. So I can just declare this over here. I don't have to do the static type annotation here because the right-hand side is a point, obviously. So I can just, write this kind of thing. Now, you may be wondering, like, where does it put those functions? Like, where does it really, declare those guys, and how does it make it accessible? So let's just take a look here. Let's do var p equals new person, not person, point of 3,4. And then I can do p dot, and you see, well, yeah, clearly the distance function lights up over there, so I can get the distance, the Euclidean distance, which will return 5 in this case, right? But I can also do point dot, and, I can get to the origin over here. Now you see something light up here, which is the prototype. And I won't go into a whole discussion of like, how the language and the JavaScript language is actually designed in terms of prototype definitions and so forth. But basically what you're seeing over here is just gonna stick some things onto the prototype. So let me go back here and just do the compilation. Just to show you that the distance method that you see on the left-hand side is actually made available on the prototype chain. So you see just point.prototype.dist equals function. So that's actually what's going on here. The thing I'm typing over there ends up on the prototype, as you can see. So that's just that piece of code. And the statics, well, the statics are just being declared on, in this particular case, the class, which is a function that's been closed over. So you see just point.origin over here for the static members. This is actually just idiomatic JavaScript. This is what you would write yourself if you were to emulate classes in JavaScript. So this actually shows a number of features of class support in TypeScript. Now we can go one step further, of course, beyond classes. We can also organize those guys in modules. So you want to have the logical organization of classes being part of modules. So you can actually put module around this, and you can say module X, or module geometry, just put this thing around it, okay? And so now what you will actually see, let me actually try to indent. This web editor is pretty good. I can just tap over there. But so the way that people have been declaring modules traditionally is actually by using this kind of pattern that you see on the right-hand side. Basically declare a function over there that, if there is no geometry yet, which is this or check over here, it will actually create a geometry that starts with an empty object. And then, inside here, it will actually put that point that I have over here. Well, it should put that point on the module. But as you can see, it is not doing that. Like, I can't access that point anymore. I can't do geometry.point. Like, it doesn't show up. Like, it says, like, I can't find a point that's available on the geometry. Now, what's going on here is that we have a notion of visibility. Like, what are the things you want to export onto the module? So that's what the export keyword is for. You can actually say, I have a module called geometry, and I want to export this class so it's available for consumers of that particular library. And so now you see that the only line of code that's been added is the line of code you would add in JavaScript yourself. Namely, you would actually stick the point onto that geometry function object so that people can discover it. And so now you can just dot into it. And again, you see that the point is available. You get the complete IntelliSense that actually shows what the shape of that object is. Now, obviously, you can actually nest those guys. You can have nested modules. You can say, I want to have a module 2D in here, for example, for 2D functionality, and so on. You can actually just start nesting those guys if you like to. But you can also name them in a way like this. Well, actually, 2D, it shouldn't start with a 2. That's the problem here. 2-dimensional, like that. Now, of course, if things get really deep and nested, you can also import modules, which is the other side of the cake, of course. You can, export constructs out of modules, but you can also import modules. So I could say 2D equals geometry.2dimensional, right? There we go. And now I can do over here 2D.point, and you see like I can just dot into those. So there's also the import keyword, which actually allows you to refer to those guys, which is a little bit like a using statement in C#, or I should say using directive. It's not a statement in that particular case. And so you see that those nested modules are actually compiled as nested functions there that actually are being put over here onto that object. So that's the way that things get exported there. Now, one more thing you can actually do here is you can, of course, also have inheritance between classes. So you can have a class that contains 2D, and then you want to declare a class called 3D on top of that one. So you also have inheritance, which is a pretty, complex pattern to get right in JavaScript yourself, because, all the instance members of a class are really copied onto the prototype. So when you want to do inheritance, you actually have to chain those prototypes yourself. And so that's actually where we can help you out as well. So I can say I want to have a class over here called point3D. Well, I should put it in a different module in that case. but let's forget about that. And I want to have this class X extend the point class that's defined on top of it. And so the way I want to extend it is by having a constructor which takes in an X number, a Y, that's a number, obviously. I also want to have a publicly exposed Z property, which is a number. And then in here, and this is actually the proposed syntax from ECMAScript 6, I can just call super with X, Y over here. And of course, I could also override now. I could also have a dist method that uses the super.dist method to do some computation, and then add some compute to it that also takes into account the z-axis in this particular case. But what's of more interest is that on the right-hand side we just emit this one helper, and in fact TypeScript doesn't have any runtime library. It doesn't have something like TypeScript.js that you have to refer in every single TypeScript program. In fact, the only helper that TypeScript emits is this extends function that's there to copy prototype chains. So that's actually one thing, that if you use the extends keyword in TypeScript, it will actually emit this little function over here, which basically checks whether it's already defined. If it's not defined yet, it declares a function that takes in a derived and the base object over here, and then it actually starts copying things around so that things are basically chained, so that you can actually call the base methods from your derived types. And so then the only thing that's going on here in the point3d definition is that the point3d definition says, well, in order to define point3d, I'll basically extend point3d based on the super type, the super type here, the base type. And then, calls to super become basically calls to underscore super that's been passed in. So that's actually the pattern that you actually have to use to do this kind of stuff in JavaScript, but now using proper syntax. In fact, nicely aligned with the syntax that ECMAScript 6 wants to add as well. But on top of that, adding the optional static typing support. So this shows basically some things around modules and classes. So now we basically talked about most of the stuff here that I wanted to talk about. So let's actually take a look at some of the code examples that come with TypeScript and see some of those concepts sort of play at a large scale. You know how to structure things in modules, you know what to do with classes, you know what to do with the static typing. So let's actually take a look at basically the download of the entire Codeplex website from typescript.codeplex.com. And so here you have a bunch of examples. So let's just, take as an example here, take the warship example. Now, what's interesting about the warship example, and let's just go here and play with it for just a second here. I could also compile it locally, but I think we have it here in run me. I can just go to the warship and just run it. So this is a very simple simple application that's just allows you to drag and drop some things using jQuery, and you can just play this battleship application. So it's a standard web application, nothing fancy there, but it's using jQuery. So let's take a look at how some of the TypeScript concepts help out here. So all I did here is I was just double-clicking the TypeScript, the TS file for my application called warship.ts. Now, one thing we haven't really touched on is that, in TypeScript, you can actually refer to other TypeScript files. So you can actually import other TypeScript files using the reference syntax that you see over there. So once you have this, you see that we can actually create a virtual project for you. So you don't have to declare the project yourself. It can basically scan the transitive closure of all the references and give you just some nice look and feel here. So now, in here, I can start playing with jQuery, for example. I can say, well, we have this thing called $. As it turns out, when you use jQuery, that $. Thing has, like 7 different definitions that show up here as just overloads. In reality, of course, like they do some runtime checks for like what the parameters are that are being passed in, but like we can model like jQuery by simply having this $. Defined somewhere. Now, where is the $. Defined? I can just do F12 for go to definition, And I can start, following this thing along, and I can see, well, this is called the jQuery static. So somebody has actually created a jQuery declaration file that takes the documentation and puts a formal contract on top of it. And so here you see that the dollar will be sitting somewhere here and will have actually the call syntax. Let me actually try to hit that one by just doing over here F12. Let's see, come on, F12. Here we go. Oh, I already was there just a second ago. Let's actually just dot a little bit deeper, and then we see more interesting things. So I can dot into this thing, and now you see something showing up here called add class. Now, what's interesting about this one is that when you actually F12 into the add class, which by itself happens to have 2 overloads, but if you go to definition, right-click here to add class, you see that this thing is defined in jQuery.d.ts, okay? So that's actually the declaration file for jQuery, and it has like, those particular overloads defined over here. However, you can also go into that jQuery object and you can actually access something called draggable and droppable. Now, if you know jQuery, those things do not exist in the standard jQuery library, but they do exist in jQuery UI, which is an additional library on top of jQuery. And the way that library extends jQuery is by monkey patching all the things that jQuery exports. So it basically injects itself into that library by basically overriding certain behaviors. Now, when I have 12 into that one, what's interesting is that now we're in a different declaration file. And you see interface jQuery over there as well. So what's going on here? We have the interface definition sitting in 2 places. So what you can do with TypeScript is you can actually layer different interface definitions, partial interface definitions, and bundle them together across different files. And so this actually models how jQuery works as well. It actually works at runtime by basically extending the interface with new capabilities. This is actually the manifestation of that. So interfaces in TypeScript are open-ended. If you have an additional declaration file that wants to add stuff, it can basically do so and simply declare that. Again, at runtime, those interfaces don't manifest themselves. They're purely a tooling illusion that says, if you refer to jQuery, you have those members. If you also include jQuery UI, you happen to have like 15 more members on top of this particular object. So that's what's going on over here. So this just shows some of the concepts in practice here. All right, so let's take a look at another example here. Another example is, for example, using Node. So I have a demo over here for Node.js. And again, Node has, as you can see over here, a declaration file that somebody in the community actually provided. This also shows some more language features like, params arrays and stuff. But this is just like, go into the jQuery, or not the jQuery, the Node documentation, and just, declaring all of those things like, there is a class called Node process and so forth and so on. So what I can do now is I can actually declare a little server here that actually imports this module. So it can actually say import HTTP equals module. And it just refers over here, it refers over here to the Node declaration file. Okay, once you refer to the Node declaration file, you can actually start playing with that API. So you can do HTTP dot, and you see just the IntelliSense showing up here in this particular case against the Node.js declaration files. So you get some very good IntelliSense here as well for the entire jQuery API, and you see things like server request, server response, and so forth, lighting up, just inside the lambdas as well. No big surprises over there. So that actually shows some other examples of libraries that actually have declaration files available. Now, when you actually have this TypeScript file, what I haven't touched upon yet is like, how do you turn it into JavaScript? Well, we've actually seen it in the browser. Right? We've seen in Visual Studio that you can just have TS files. How do they get compiled? Well, there are a number of different ways of doing things. I will show you one for a Windows 8 modern UI application in just a second, but you can also, be the real geek and just, use command line tools. So you can just go in here to the demo Node directory where I do have that TS file, and I can just write TSC for TypeScript compiler, and I can pass in here server.ts, for example. And what it's done right now is actually it's just created over here a server.js file. You see it's emitted it at exactly that time. I also saved it in Visual Studio, apparently using the same during the same minute. But so if I open server.js and just take a look at how it compares to the thing we have in Visual Studio over there, you can see it's essentially the code that I wrote, just with some different indentation over here. But one thing that's different over here is that the module, that actually TypeScript supports different module loaders as well. So in this case, I was using module HTTP, and you see that, in here, it actually translates into require HTTP, which is the package mechanism that's used to actually access Node APIs. In fact, I can go even do F12 on the HTTP module over here. Module is a built-in keyword that takes in a parameter. So I can do F12 on HTTP, and it actually just goes to the declared module. Modules can have a string as a name. So here you see a module defined as HTTP, which actually contains the server and all of that stuff. So you can basically just F12 into those. It's pretty much the same thing as doing like go to definition in C++, where you can do go to definition for a .header file. It's a very similar kind of mechanism here. So that actually shows Node. Now let's actually do one more example here. Let's do the example of Windows 8 application. So of course, you don't want to muck around with, things like command line tools all the time. You may actually want to have some more integrated experience. So just for full disclosure, TypeScript is a preview. So we don't have rich templates available just yet for things like, Windows 8 applications and things like the ASP.NET applications. However, it turns out it's pretty simple to actually just use TypeScript over there. So this is just an encyclopedia application that ships with TypeScript as an example. And so in the JS file, or in the JS folder over here, what I really have is a bunch of TS files. And the only thing that's been configured for those TS files is actually a TypeScript compile action. So you can actually configure that for files. The only thing it does is whenever you hit save for the file, it calls a TypeScript compiler to generate the corresponding JavaScript file. So you can just write your code using TypeScript, and you see it just compiles all of the TS files into JS files as soon as you hit save on them. And so what's interesting about this one is that it actually imports the Windows, the Windows XAML stack. The Windows modern UI stack here. So what you see is I can just dot into Windows, and I can start exploring over here. Took a while to come up, but you see I can just explore things just like you can explore them in C# and Visual Basic. Now what's really going on here is that Windows is defined in some module called winrt.declaration.ts. Now, this file is actually a gigantic file. It's 18,000 lines, but it was not written by any human. We simply took the WinMD files from WinRT and generated TypeScript definition files for them. And out of the box, now you get IntelliSense, in TypeScript that can just dot into the entire WinRT APIs. And so this is just, generated code that just starts from the definitions of the Windows APIs. In fact, you can really go crazy here. You can actually extend, existing classes that ship in WinRT. You can just build, derived classes on top of that over here, just using the same concepts that we've actually looked at before. So that's the idea of this one. In fact, there was some interesting piece of code here, just to show you how types really flow. You see things like, for example, on query submitted for the search char. That's the search pane that's been used here. And, we could actually take out some of those, event-like things here, and types would still be flowing. It's just actually typed pretty explicitly over here. So, we have this rich, optional static typing. You can put it everywhere if you like, but you can take out a lot of that stuff, and the tooling just lights up, as we've seen before. Now, just to wrap up, let's show you, well, actually, I can also show, of course, that this application does run and does something, but, I'm more of a language guy, so, I'm not quite interested in seeing it run, but just in terms of how you write the code over here, You can just go here. In fact, we also support source maps, so you can actually set breakpoints in the TypeScript. There's still a little bit of tooling to be done there, but you can set breakpoints and just, don't step into the JavaScript, essentially. You can just go there. So one more thing I wanted to show you is, some of the rich tooling we've already seen. We've seen you can just, get IntelliSense, you can go to definition, but there's much more you can do once you have this, optional static type information available at development time. And so just to show that, let's open one more example, which is the TypeScript compiler itself. So when you download TypeScript, you will actually just get the compiler, which is written itself in TypeScript. That's every compiler's dream, right? Compiler writers love to write their compilers in the language they're compiling. And so that's really what's going on here. I can just double-click ast.ts, and after just a second here, you see that there's a new virtual project being generated over here, just in memory, that contains the entire TypeScript compiler. Now, again, I didn't have to declare some tsproj file or something. It's just chasing all the references from the file I opened. And it turns out that AST, is referring to TypeScript.ts. So you have this, ability to organize your code by having references in a way that you're actually used to from different places. Now, this thing refers to TypeScript.ts, which is actually the main file for the compiler. So I can go here, and you see this thing refers to, basically everything in the compiler. You can just go in here. It's a pretty interesting read. To start going through it, I just want to show you one thing. I want to show you some code navigation features that, well, we've already seen, but just to show them in practice. So this is the main entry point for the TypeScript compiler. You can simply new this thing up, give it a string from TypeScript, and now it comes, a JavaScript string, which is what you expect, of course. But internally, it contains a parser, which parses the code. And the parser, I just did F12 there, go to definition. The parser contains a scanner, which is, the thing that lexes, the things and tokenizes your code. So I can just go to definition over there. And so I'm now starting to just browse this code. And, I can just, browse the code in any convenient way. I can just jump to the members and all of that stuff. So I have very rich tooling support here. But one more thing I can do is I can go in here and see, well, this scanner actually has some line property defined on it, which is a very natural thing for a scanner to have. Let me see where all of those things are being referred to. And so because we have the optional static type information and we know, that something refers to the scanner class and, accesses the line property somewhere, we can actually find all of those sites that this thing has been used. Now, in particular, if I go up here, and I just double-click one of those use sites, you see that this piece of code is actually throwing a syntax error for some reason, referring to the scanner.line, and you can basically see, what the types are. That's pretty neat, of course. But what's interesting is that there is another line sitting right up there, another thing called line as well. Now, if you were just, writing JavaScript code here and you would say I really want to rename this variable to line number instead, well, you would be kind of out of luck at that point, right? What you would have to do is you would have to search your entire code base for everything that contains line. And for every single thing that's called line, you would have to make a judgment whether, at the runtime, that really means the line from the scanner or a line from something else. You don't have any type information around to help you trace those things back. However, here you can simply do this. You can just say, let me just go to the definition of line. And you can just right-click here, and you can say, I want to rename this guy, from line to new name, should be line number. And there we go, and TypeScript is basically chasing all the code. And now, as I, right-click and, find all references for this one, the new line number, you will see it didn't touch the line over here because it wasn't the same line. It's just something that happened to contain the same name. And this is the kind of tooling you simply expect from things like, statically typed languages like C# and Visual Basic, for example, but now also brought to JavaScript using this optional static type system that you can layer on top of JavaScript execution. At the end of the day, there's no runtime artifacts of any of this. Like, there's the types simply race out. You don't have any runtime artifacts that have to do with the types. So it's still as efficient as it would be without having that information. Now, in fact, one more thing that will be added most likely in the next updates to TypeScript is support for generics. So you will actually have the ability to declare some generic interface where you say, like, I want to have an array of T or a list of T or something like that. Again, there will not be any runtime manifestation of those of T's. They will all be erased out at compile time, but you get the great IntelliSense experience and the great, compile time support at development time. So you actually find your bugs early. So let's just wrap up here with a couple of closing notes. So at the heart of TypeScript is, of course, the types, right? Otherwise, it wouldn't be called TypeScript. Essentially, what it is it's basically capturing the meaningful subset of JavaScript execution that happens at runtime, but it formalizes it as a type system that's there simply to assist you writing your code at development time. So it's a static representation of what's really happening at runtime. And so it's really a model on top of things like, all the monkey patching that jQuery is doing. You can describe it using declaration files. As we've seen, we have type inference. You don't have to put a lot of type annotations to see things start flowing throughout your code. Declare something as a number, you do some additions, things are being inferred to be numbers and so forth. It works with existing JavaScript libraries. We've seen we can interoperate with things like jQuery, Node.js, and so forth. The only thing you actually have is declaration files, which are written completely separately from the underlying runtime libraries. It's a little bit like header files, and libraries underneath. And for the people who are really into type systems, this is not a provably safe type system. It's basically there just, for compile time support. It's not something that's enforced at runtime, for example. Okay, so we've also seen classes and modules. Classes and modules allow you to really structure, large code bases, which is really what people want to do with JavaScript today. And, it turns out there isn't any good support for that. However, there is some ECMAScript 6 proposals that deal with classes, modules, and something I haven't talked about here, arrow functions, that solve some mysterious issues with the function keyword in JavaScript. But so TypeScript is aligned with ECMAScript 6 in terms of those features. If ECMAScript 6 changes, TypeScript will most likely follow as well. But the thing we add on top of that is actually the optional static typing. And we also support popular module systems like, the asynchronous module definitions, CommonJS, and so forth. I've actually seen a couple of instances of those where for Node, I was actually using the import keyword and it was using the require system behind it. The different things are supported over there. So, what's in the preview that you actually can download? Well, we do have the TypeScript compiler, of course, which, as you've seen, is just written in TypeScript as well. You can play around with it. If you find any issues, you can actually, upload them on Codeplex and let people review them as well. We have tooling, which is the Visual Studio Language Service, for example, is entirely based on exactly the same code as you see in the web browser. So in the web browser, you get IntelliSense. It's exactly the same language service that's been hosted in Visual Studio using the Chakra engine, the JavaScript engine. We have libraries, so we have some declaration files that come in the box for things like jQuery, Node.js, and so forth, WinRT. But we actually see the community actually creating a whole bunch of declaration files for other libraries. So, contributing libraries or, declaration files is always super nice as well. And of course, the distribution also has a language specification. If you really want to learn, all the intricate details of how the type system really works, you can just go and dive into the language specification there. So with that, if you have any questions, I'll be around. There's also, some other talks I have today. There's in fact an unplugged session where you could ask some more questions about TypeScript. I'll likely talk about some other things like C# and CLR as well. But in case there are any questions, I can take them right now. And I think it's about time to get lunch, if I'm not mistaken. I hope I don't make false promises about lunches when it's not lunchtime. But Okay, thanks for your attention and hope to see you again.